Welcome to the High Top Industrial channel. In the world of precision manufacturing, materials aren't just objects to be processed, they have their own personalities. When selecting materials, we often hear phrases like, "This steel is very hard," or "This alloy is very strong." But did you know? In engineering terms, hard, strong, and tough represent completely different physical destinies. Today, we're digging deep into these three core concepts to help you avoid expensive material selection errors. Many people conflate these terms, thinking that hard implies strong. But for engineers, confusing these concepts leads to catastrophic consequences. Imagine this: an extremely hard cutting tool might suddenly snap during machining because it lacks toughness, while a high-strength structural part might wear out rapidly because its surface is too soft. To make precise decisions, we need to know how to read a material's medical report. First, let's talk about strength. In engineering, strength isn't just how much force it takes to break it. The most critical concept is actually yield strength. Look at this curve. Before the yield point, the material acts like a spring. It deforms under load but bounces back. Once you cross this point, the material undergoes plastic deformation, meaning permanent change. For most mechanical parts, permanent deformation means failure. So while we care about tensile strength, in design we are more concerned with when it will yield. Additionally, depending on the direction of force, we must consider compressive strength and shear strength. Next up is hardness. If strength is the ability to resist overall deformation, then hardness is the ability to resist localized surface deformation. Think of it as the material's armor value, specifically resisting scratches, cutting, and wear. At the microscopic level, high-hardness materials have atomic structures that are locked tightly together, preventing atomic layers from sliding over each other. This is why hard materials like diamonds, ceramics, and hardened steel are typically very wear-resistant. The industry commonly uses Rockwell hardness to measure metals. Simply put, a diamond cone presses down with a specific force. The shallower the indentation, the higher the hardness. But remember, high hardness usually implies brittleness. This brings us to our next key player, the most misunderstood, yet most life-saving property: toughness. Toughness is a material's ability to absorb energy before fracturing. It requires a material to have not just strength, but also ductility. Sound abstract? Let's look at an example. Glass is very hard and has decent tensile strength, but its toughness is extremely low. Hit it with a hammer and it can't absorb any energy. With nowhere to go, that energy causes it to shatter instantly. In contrast, high-toughness steel will digest that energy through its own deformation when hit by a massive impact. It bends rather than breaks. This is crucial in automotive safety design. The safety cage needs high strength to maintain survival space, but the crumple zones need high toughness to absorb the kinetic energy of the crash, protecting the passengers. In short, hardness resists scratching, strength resists deformation, and toughness resists fracturing. Since these three properties are so important, can we have them all? Unfortunately, material science is often a game of trade-offs. Typically, increasing hardness comes at the expense of toughness. Extremely hard tools tend to be highly brittle as well. This delicate balance, however, is precisely the reason behind the failure of many projects, for it is exceedingly difficult to find that perfect intermediate point. From the extreme toughness required for deep-sea drilling equipment to the heat-resistant hardness needed for aero engine blades, understanding material properties is the first step to manufacturing superior products, no matter what physical challenges your project faces. High Top Industrial provides professional material advice and manufacturing solutions. Contact us and let's build a stronger future with the right materials.